So in this problem, the following data was collected on height and weight of women swimmers. And the first thing we need to do is to develop a scatter diagram for this data with height as the independent variable and weight as the dependent variable. I've gone ahead and created a coordinate system for the height and weight. Notice that the heights go anywhere from 62 to 68, so I decided to break the x-axis a little bit, start at 62 and go 1 inch at a time up through 68. And then the vertical axis, you don't want to break the vertical axis usually, because if you're looking at a graph you want to make sure it's proportioned correctly as far as the output. I'm going by units of 20. The weights range anywhere from 102 to 132, so I went by 20s up to 160. Now I need to just plot the points, and to do that I'm going to take the 68, first one, and the 132. I'll just kind of roughly sketch that in, maybe about right there. The 64, 108, maybe about right there. The 62, 102, and 65, 115, and 66, 128. Okay, we have the points plotted. Now we want to draw a regression line through the data set. And to do that, I will try to approximate that, drawing a line through the data, sort of averaging its way through the data. Now I want to find an equation for that line. And the general form of the equation is, and to get the slope of my input variable, the height, or x in this case, there's a formula for that. The slope is given as b1, and if I look at that formula, I'm going to need to make some calculations in the table on each of the height and weight values. So I'm going to go ahead and set up a table so that I can make some of these calculations. I would need to calculate for each x value the difference between it and the mean, and each y value the difference between it and the mean. And I'll need the x bar and y bar to do that. The x bar is the sum of the x values divided by the 5 values equals 65, and the y bar is the sum of the y values divided by the total 5 and giving us 117. Now I want to subtract the x bar value from each of the x values to make up my next column. So 68 subtract 65 would be equal to 3. 64 subtract 65 is negative 1. And then I'd have negative 3, 0, and 1. For the difference of the y values in the mean, I would have 132 subtract 117, or 15. 108 subtract 117, negative 9. Then negative 15. Negative 2, and 11. Now I want to multiply these values. By the way, again, these columns are all the values I need for my B1 formula of the slope. So this is part of the numerator that I'll have to add together, and I've got to get these products. So I'll take 3 times 15 to get 45. Negative 1 times negative 9 to get 9. Negative 3 times negative 15 to get 45. And then 0 and 11. I'm also going to need to find the x sub I minus x bar values squared for the denominator. So 3 squared is 9. Negative 1 squared is 1. And then I would have 9, 0, and 1. Adding these last two columns together, I will get 45 plus 9 plus 45 plus 0 plus 11 is 110. 9 plus 1 plus 9, 0 and 1 adds up to be 20. So in my formula for B1, I will have 110 divided by 20 equal to 5.5. There's also a formula to calculate the B sub 0. It is the average of the y value, subtract the value I just calculated for B1 times the average of the x values. So taking y bar at 117, subtract 5.5 times x bar at 65, I get a negative 240.5. So my regression equation, my estimated regression equation is negative 240.5 plus 5.5 times x. And this is the equation of the line that best approximates that data. This is a algebraic function, if you will, a linear one, that I can use to estimate the weight of any woman swimmer given her height. So that now I have a relationship between the height and the weight, a mathematical one, so that for any height I can calculate the corresponding weight, not just the 5 individual data points that I collected, but now I can estimate the weight given any height. And this is a very powerful application of statistics. Now, to estimate the weight of a woman swimmer that is 63 inches tall, I have a formula that I can do that to estimate. I will plug in the 63 into the regression equation. And if I do the calculation there, I get 106. So 106 pounds. So 63 inch tall would correspond to 106 pounds based on all the data that I collected. That would be the predicted amount. Let's go ahead and graph that. 63 would be my height. So I'm going to really kind of rough sketch this. And so at that point on the line, 63 corresponds to the 106 pounds. So that's a rough sketch, so it's not perfect there, but hope you get the idea. At any rate, I created an estimated regression equation between these two variables that I collected data on. When I graphed the values between these two variables, I saw that there was a pattern there. It looked roughly linear. So I created a best fit a linear function that would fit the data, and then use that function to predict weights of the women swimmers given the height.